Here is a problem. A boat leaves dock at 2 p.m., travels due south at the speed of 20 kilometers per hour. So for any kind of problems which have directions, I try to draw my directions. Say this is north, south, this is west, and this is east. So one boat is traveling south at a speed of, so it started from the dock. Let's say the dock is here, D at the center. And one boat is traveling south with this direction at the speed of 20 kilometers per hour. Okay. Another boat has been heading due east at 15 kilometers per hour. So this started at 2 p.m. Another one is coming towards east and reaches the dock at 3 p.m. and it is coming at 15 kilometers per hour. So if it reaches at 3 p.m., that means in 1 hour, right? Because it's all started at 2 p.m. So that means 1 hour, how much it would have traveled? 15 kilometer. That means it's on to the left of the dock, 15 kilometers. It traveled for 1 hour to reach the dock at 3 p.m. So the red one reaches the dock at 3 p.m. The blue one starts the dock at 2 p.m. That's what it's given. At what time were the two boats closest together? So what are they asking? What is the question? What we need to optimize? What time the two boats were closest together? For example, let's say at some time t, this is here and this is here. At this time, this is the distance. We want this distance to be minimum distance. Okay, at some time t, this was coming this way, this was going this way, right? So what is the distance of the blue boat? Let's first figure out the blue boat. That is easy one. So it is traveling at 20 kilometer per hour. In t time, it would have traveled 20 t. Okay, so we are saying at time t, the distance is some distance, right? We have to calculate that. How much the other boat has traveled and that much time? So it's traveled 15 times t in that much time, but it was already in which it was starting from this point. So it's come how close? What is the coordinates of this point? That would be negative 15 plus 15t. What will be the coordinates of this point? The x coordinate is 0, the y coordinate will be 20t. Okay, and the x coordinate of that is negative 15 plus 15t, and the y coordinate is 0. Now we want to calculate the distance between 2 points. Note down, if we have 2 points x1, y1 and x2, y2, the distance between the points is given as x2 minus x1 whole square plus y2 minus y1 whole square. Using this formula, I can find my distance at time t as x point formula. So 0 minus negative 15 plus 15t square plus y minus 20t minus 0 whole square root of the whole thing. Okay, x2 minus x1 plus y2 minus y1. So basically negative square is finished. So we have negative 15 plus 15t whole square plus 20t whole square. We want this function, this is our function. We want this to be minimum. Now, square roots are difficult to handle. Why don't we just consider what is under the square root? If that is minimum, the square root will be minimum, right? So negative 15 plus 15t whole square plus 20t whole square. We are saying if f of t is minimum, then the boats will be closest. Do you guys understand that? Because this is under the square root. If under the square root term is minimum, then the square root of that will be minimum. That is a distance actually. Okay. How do we figure out when is this minimum? Before even I get there, can we actually just simplify the function, right? We need to open the square of this. The square of this is can be opened using a minus b whole square formula, which is a square minus 2ab plus b square. So this should be 225 minus 2 times 1530 times this 450t plus 225t square plus this is 400t square. So we have 225 minus 450t plus 625t square. We want to minimize our function. Our goal is to optimize this function. This is our function. Once we have our function, we can find the derivative. Okay, the derivative of this is negative 450 plus 2 times 625. So that's gonna be 1250t. Okay, that's my function. Next derivative, I want to find critical points. Critical points are where f prime t equal to 0, meaning negative 450 plus 1250t equal to 0. We do not need to do f prime t does not exist because f prime is a polynomial. It exists everywhere. So t is equal to 12, basically 450 goes on the other side, divided by 1250. Okay, so we can divide this using the calculator. This is given as 0.36. So this is in hours because the time was in hours. So 0.36 hours. So in 0.36 hours, the distance would be, distance was this, would be the minimum. Okay, because that is our critical point. So if you want it accurately, 0.36 hours is equal to 0.36 times 60 minutes. You want to convert that into the minutes. That is 21.6 minutes. You can further convert that into 21 minute plus 6.6 times 60 seconds. Basically 21 minute and 36 seconds. Okay. In that much time, the distance between two boats is minimum. How do we confirm minimum part though? We can find the second derivative of the function. We have our first derivative. Differentiate that to get second derivative. If you see, the second derivative is coming to be 1250, which is always positive. Okay. So because second derivative is positive, we can confirm function is minimum at t is equal to 0.36 hours. If function is minimum at that, we can say boats are closest after 0.36 hours or in 21 minutes and 36 seconds. So at what time were those two boats together? That is after 2 p.m. because the boat started at 2 p.m. 21 minutes and 36 seconds. At this time, boats were closest.